Hey everyone, so today we have Patrick here, and we're gonna be going through a coding interview focused on dynamic programming. But yeah, want to introduce yourself, Patrick?
Yeah, my name is Patrick. I'm a second year computer science student over in Dublin. I make YouTube videos about coding, lifestyle, coding interviews, talking about my journey and as to how I've gotten so many internships in my first and second year. So now I'm here with James,
Yes,
and he's gonna put me to
sir.
the test.
Let's get it. Everyone, go follow P Codes. It's gonna be linked, but we're gonna collab on the video. But what's your favorite language to code in when you do interviews?
For me, it's Python, simplest,
Python.
fastest to start with. Yeah.
So like anybody, for anyone new to your channel, what is your technique or what's the TLDR on how to get interviews and stuff and jobs? 'Cause you said you have content on that they can look at your channel for, but what would be the TLDR if they're just tuning in to see this right now?
Yeah, I guess what really worked for me in is getting a lot of projects out there, just getting physical proof of your learning, physical proof of your skills that people can see. And when recruiters can actually see evidence of your skills, they're going to believe you more that you're going to be able to be efficient on the job
Hmm.
rather than somebody that says, I know this language, but they haven't showed me anything. I feel like having a lot of projects out there gets you a lot of trust with recruiters for
Nice. So
sure.
that you think that was your competitive advantage, just actually having projects?
Yeah, I had a lot of projects going into applying for jobs, so
Nice.
that was it.
I mean, a lot of people always ask this question where they're like, "What is the best project to work on?" Do you have any advice for them?
Best project to work on? Hmm.
Or like, what project
Um,
should they work on? Because that
I f-
people would like.
okay. Okay, I feel like kind of like look at the role that you want to get into. Like obviously you want to get into software engineer, web development or something like that.
Yep.
Okay, go into something web development. And then if you know you want to be web development, create a full stack app. And then depending on where you're I say like depending on where you want to get to, because certain places use certain different like frameworks and tools, but like kind of like look at a general one. Like let's say you know Java Spring Boot, then most backend places will be able to take you if you have a Java Spring Boot project,
Hmm.
making an API with that. So like that's how I see it. I see like what role do you want to get into? What are the like common technologies used around that role? Learn those technologies and then make a project to show that you know them technologies. That's the way I approached it.
Nice. So with you, did you figure out what companies you want to work for and then kind of work backwards, or you just touched a lot of technologies with all the stuff you did and just
I
tailored
kind of
it?
I kind of just looked at like first for the first application stage, I just looked at like what roles I wanted to get into, which was software engineering on the web development side.
Yep.
So I learned both front end and back end, so I can appeal to both front end and back end kind of thing. But then going among along the recruitment process, I started to learn the specific technologies for companies.
I
Like
see.
for instance, for HubSpot, I started to learn like a really in depth JavaScript and things like that. So then going into the interviews, I know a lot and then be able to show them a lot kind of thing.
All right, perfect. Okay,
Hmm.
let's get into this question. That's solid advice, honestly. Really
Hmm.
good advice, especially you're in your second year. You already know exactly what to do, which is good.
Hmm. I try my best.
So we're gonna be working in Python. What we're gonna be designing is what we want to do is be able to count the number of unique tic-tac-toe finishes.
Okay.
So tic-tac-toe is a 3 by 3 grid. Essentially, X starts first, and then you alternate between X and O's, and then somebody wins if they get three in a row, and that could be like diagonally or vertical or horizontal. Could also be a draw, but we just need to count the number of ways that it could finish the tic-tac-toe. And this is kind of a long question, so try to break it down into its parts. You could even brute force it first and then optimize from there. But like, let's just spend the whole interview working through this question and get something like production ready out.
Okay. Okay. Let me just read this for a second, then I'll repeat it to you. That's what. Okay. So we're working with a standard 3 by 3 tic tac toe board. Two players. X goes first. Then players alternate turns. Okay. A game ends immediately when one player wins, which is three in a row. Could that be like upwards and across?
and diagonal.
And okay, upwards, cross, and diagonal. Cool. Or or okay. The board is full, which would be a draw. Okay. Want to count how many different ways a game could finish. A way to find the sequence of moves, not just a final board. Okay. Okay, so from what I understand, we're given a 3 by 3 board, and obviously player X, we have two players, let's say X and Y. Player X goes first. They can either choose, hold on. Did I forget how tic-tac-toe works?
We here we could play it right here. Go come to the drawing. It's kind of
I think
like you just
where?
make a board like this, and then if you go into the drawing,
Oh, like X's and O's.
X, yeah, like you
Oh,
could win
okay.
if somebody gets like that, right?
Oh, okay, okay,
And then you
okay,
just
okay,
kind of
okay.
alternate.
Okay, okay.
You remember
Make
this
this
now,
drawing
or
repeat.
yeah, we could.
Yeah, I remember it now. We just never called it tic-tac-toe. That's why I was
Oh,
confused.
I see.
Okay, okay, okay.
So let's play it real quick. Like
Hmm.
I start with X, and then you have to do a O, right?
Okay, so we're
Just so
actually
you
playing this
understand how
live.
the game is.
After an
And
O,
then
then
like I can try to here, and
okay,
yeah, you try
after
to
there.
stop me. You know what I mean?
Okay. Yeah, yeah, okay. I see, I see, I see.
And then
So it's
what would you
like,
do here
mhm,
next? Because you go,
and I win here.
you win, yeah, right. So that's one
I
finish.
capiche.
What are the number of ways that we could finish the game?
That's one.
That's
Right
one.
now, we have one. Yeah.
Yeah,
Okay. Okay. So I see. It's like I see. So every time a user can put down a sorry, can place anywhere pretty much that's not used, of course.
exactly. Not used and
Okay. Okay. Let me read into this. Okay, so we start with player X, and player X can place it anywhere. So I guess I'm trying to see how I can build up like decisions, like what decisions I'm making every time we go through this board. It's a it's always 3 by 3. It doesn't increase, right? Always
yeah,
three
it's
by
just
three.
gonna be a 3 by 3 board.
Okay. So I guess every time, let's say we were to traverse this board, I'm thinking every time we traverse this board, there could either be an X or an O. Mhm. It could either be an X or an O. So I'm starting to think immediately. Obviously, I can start at the first. You seeing the drawing here? I can start at the very first. Can you see my drawing?
Yep, I can see your drawing.
Yeah. Okay. Like, let's say we start at the very first index. We can either place an X or place an O, and then at the next one we can either place an X or place an O, and then the next one, and then we just do that the entire time. And then anytime we encounter a finish, we increment a count, and then we go back to the beginning. But go back to the beginning again and try. Like, let's say over here we try with wait, where's the eraser here? I don't, oh, here. Okay, so let's say I think this is kind of like a brute force. It's like kind of just jumps out to me straight away.
Yeah.
But like obviously at the first index, this could either be an X or an O. So I immediately choose, let's say I go with X. I then continue the game on every index I go to. I choose whether to place either an X or an O. And then I continue and continue. And then after I'd finish, let's say this was X, X, O, X, and then I'd finish all of this. I'd go back to each index and then change my decision to an O and then do the same thing again. And then every time we encounter a win, I would increment a global count kind of thing.
Okay, so for
You understand what I'm
each
saying?
index, we're trying a different element, like an X or an O there.
Exactly. And then we backtrack and then try the other decision and then see how many results we can get from that one. Does that make
Hmm.
sense?
Wait, so okay, let's go back here real
Hmm.
quick.
Yeah.
So suppose we put an X, right?
Hmm.
And then later we're gonna try to put an O here, like when we
Yeah.
backtrack. Is that
Yeah.
valid though? To put a O? We said X will always go first, right?
X will always go first. That
Or it
is
has
the
to
thing that.
alternate. So we can't. This is not a valid state if there's two X's in a row.
Hmm. Hmm. Okay, that does. Okay. Hmm. Okay. So two x's is an about state. So we're gonna go x. We always have to alternate. Hmm. And okay, obviously we can place anywhere. So, but I'm just thinking I can't just go looping over the whole grid over and over again and choosing a random place to place something. But let's start off with x. Hmm. Okay, let me think about what we know. So we know x has to start. X has to start, and x can be placed anywhere. Then we have to alternate. So obviously, throughout our whether it's a recursion or anything, we're going to be keeping track of if it's x's go or if it's o's go. So like p1's go or p2's go. Okay.
Yeah.
But how? Okay, how do I then? Should I like run this simulation? How would I run this simulation here? That's what I'm thinking of right now. Hmm. If you place x, sure, start off with x, then O can go anywhere. But this is start with x. Okay. Hmm. Okay, I'm kind of thinking. Let's say we go through. Let's say we loop through the board once. Obviously, x can be placed anywhere.
Yep.
And so then we place x at any point,
Sure.
and then we'd mark that point as obviously seen.
Mm-hmm.
Then, like I say, we're doing this recursively. Choose any point that's not seen. We paste down the x, right? And then
Yeah.
now, next time we go through our recursion, we know it's O's turn. We choose any point that's not seen again,
Mm-hmm.
and then let's say like here, okay. And then next time we know it's X's go. Choose any point that's not seen, which could be anywhere here. Choose any point that's not seen.
Mm-hmm.
Choose any point that's not seen. So I guess we can choose every point that's not seen actually. So how I'm thinking of this is, let's say, oh, I'm deleting the board. Let's say with X right now, all points are not seen, are not
Yep.
in scene. Obviously, I have some sort of set. All points are not seen. So we
Mm-hmm.
can try place X here. Then cool. Then we now go to the next iteration or recursion. Next function call. Now we can choose again any point that's not seen,
Yep.
where then we know to place O. So then let's say we placed O here, then
Mm-hmm.
if that's the same thing. We then know, okay, let's see where we haven't seen, where there isn't anything, sorry, where there is no X or O,
Mm-hmm.
we'll try to place an X there and then see if we can build something out of that. If you know what I'm saying?
Yep. And then
Like,
what? Like when does it stop?
when it will eventually stop when either so as I'm going through this recursion, I would also keep track of in the scene set. We'd have like an overall scene. I don't know how many scenes, but like I would have a scene set that'll keep track of how many X's are in the current like row and how many are in the current column, as well as how many in the current diagonal. So the recursion would either stop at when we reach three in a row in any of them three slots, the row, col, or diagonal, or if we reach all, if like the full if we've already traversed the whole thing, the whole board, kind of thing.
Mm-hmm. Okay.
Does that make sense? And I think I can repeat it again if you want
Yeah.
me
No.
to
No.
start.
That makes 100% sense. So you talked about the recursion and stuff. Is there any other aspects of the question we should talk about?
Okay. You mentioned counting how many different ways the game could finish. So obviously, if we ever hit a three in a row, I would I would immediately return as well as increment a global count. So then I'd be able to build up our result based off of that kind of thing.
Mm-hmm.
But what else? Let me just make sure I'm not missing anything here in the question. I'm just gonna repeat it again. X goes first, and players alternate. Game ends immediately when one tree in a row or the board is full. We count how many different ways a game could finish. A way is this defined as a sequence of moves, not just the final board. Okay, when you say a sequence of moves, So okay, you already showed me before that, oh, like this is one way. X X X, oh, like sorry, my writing's really bad. But
Yeah.
yeah, that's one way.
Yeah.
Doesn't matter how it is, even if this was like this, like that's still just one way.
Yeah.
Okay. Okay.
Or like we can get to the same state in multiple ways. That makes sense.
Hmm.
Like
Can you say what you're saying?
so what's the number of ways that we can get to x o x, this state right here, x o x? We can kind of get there in like two different ways. Either I start x on this is the first one that I place, and then they put o, and then I put x here, or I start with this x and they put o, and then like there's two ways
Okay,
to get to
so
this state.
to get to this, oh, these consecutive three X's, would you want to count that as
Or are you
still
looking?
that's just
Oh, sorry,
one?
down here. Are you? I
Oh,
know
oh,
it's a
where,
bit
where?
slow sometimes. If you scroll down a bit,
Oh, it is really slow. Oh, I
yeah,
didn't
it's
even.
really slow.
I did not even see all of this.
Yeah.
Sorry.
So like, how many ways can we get to this state?
So wait, right now I'm seeing two X's and an O.
Yeah.
Okay. Okay. Wait, sorry. What exactly you're asking?
Like, how many ways could we get to this state right here?
The state where this one X here,
Yeah.
and then I'm gonna hit the right.
Yep. This exact
Hmm.
state.
So I guess this could happen like X O X. Well, this could not be. Well, it could only be X then O then X. So would it not be just be one way?
But yeah,
Or
but
I
then
don't know.
I
Like,
could place it's the first X over on the left corner, and then they go to O, and then I put on the right. Or I could start with the right,
oh,
and
okay.
then that. So that's two different paths, right?
Would that be counted as two
Yeah.
different?
Yeah, that counts as two different paths.
Okay, so by the way my recursion was designed, that would take account for that as well.
Yeah, yours would do it. But yeah, just want to
Okay.
clarify that.
Okay, cool, cool, cool. Okay, cool, 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 cool. So I think, would you like me to code out that brute force?
So how are we gonna store the state and then like track the turns? There's like multiple ways
At
we can store the state. So yeah, let's talk about that part for a little bit.
storing the state, I guess like
What?
an
Yeah.
overall scene. Let's say we had like a scene set here for like all columns that have, or I guess I don't really need a scene set. I could just have, okay, the current call, like a dictionary for columns, which would have column, let's say like it would map column 0, and then it'd have like hmm, let's say a list, and then the first index would be how many X's, and then the second index would be how many O's. I'm thinking of that right now. Then with row, we'd have um let's say like row 0, we have 0 X's, 0 O's. And then for the diagonals, I'd have to, okay, there's a positive diagonal and there's a negative diagonal. Okay, okay, okay. And how I'd keep track of the positive diagonal is the one going downwards, right? Or is that negative?
Mm.
Right? Positive
Or
diagonal is one going downwards. Like from
yeah,
like
maybe it
like
depends.
I'm just gonna assume it is. So the way I'd keep track of this is using, I believe, row minus, so row I think it's row plus. Okay, so like if I'm in the top left, row plus row would be 0. If I'm in the middle, row plus row would be 2. If I'm on the right, row plus row would be 4. Okay. I think for positive diagonal I can use row plus row. And then with that I can keep track of the wait, not row plus row. Row minus column. That's how I keep track of it actually. Because obviously with 0, 0, row minus column would be 0. And with index 1, 1, row minus column will be 0. And with index 2, 2, row minus column will be 0. So then that let us know that that's how I keep track of all the different things we've seen in the diagonal.
Mm.
Does that make
Okay.
sense?
Yep.
So this would be row minus column. Let me just, sorry, that's row minus column is the key. then the value would be again how many x's, how many o's, kind of thing. And then with the negative diagonal, I'd have, I believe, let's say I'm trying to visualize this again. If I had an x here and then a x here, this would be row 2. This would be row 2, column 0, row 1. Sorry, row 0. I'm building. Yeah, sorry. Row 0, column 2. This is row 2, column 1. Then this is row 0. Okay. How would I keep track of this now? As I'm going downwards. So here, I'm thinking of row plus column. Oh yeah, because 0 plus 2 here would be 2. So obviously row 0, column 2, which would be 0 plus 2 is 2. Is 2. And then over here, we'd have 1 plus 1, which would equal to 2. Then over here, we'd have row 2, column 0. Okay. Which is also equal to 2. So then that's how I keep track of the negative diagonal. So I keep row plus column.
Nice.
And then again, the same thing. So I'd have all these dictionaries to keep track of row, column, positive diagonal, negative diagonal. Keep track of how many x's and o's we have for each one.
Okay.
Okay. Then
So
sorry.
like we're gonna, for column and row, we're just gonna store. Do we care about like the actual position? As in like in a column, if it's in column 0, we just care that it's. Do we care where it is in that column, or no? Like is the first element in that column, the second element, the third? Would that matter at all for the solution?
So that I guess we do need to keep track of if of obviously what specific column you've seen, what specific row you've seen, so that we don't end up visiting that again. So I'm thinking I might need another scene and scene set, and obviously this would just be a set containing tuples of row column that I've been seen. I feel like later on I might realize that I don't need this many dictionaries, but I believe with this I'd be able to safely keep track of all I've seen and the count of the amount of X's and O's for each.
Yeah.
So yeah.
Maybe let's think about this for a couple minutes in case there might be like easier ways to model the state. Just because it
Mm,
could get complicated in your recursion. I don't want to debug
mm.
during the recursion because that'll be tougher. Like,
Okay,
or just make
okay,
sure that
okay.
you ironed out how you're going to like manage these
Okay,
during the
so like
recursion.
I'd say my recursive. I'm trying to think how I'd model the recursive function. Cursive would carry. Hmm. Okay. 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 I think like on my first function call, I'm trying to think. Call row pause like that. So like obviously I think I'll be passing obviously R first. I think the main thing I know I'll be having is X. Let's obviously be a Boolean if it's X's turn or if it's Y's turn. So then we'd have the call dictionary, the row dictionary, pause tag, and hmm. No, I feel okay. These are all going to be outside of the function calls, right? And then obviously as I go along, I'd call it, let's say, um, for row in range 3 or something like that, right? And then for C in range 3, I'd say, okay, if row and call is not in scene, thinking if the row or column is not in scene, we then call the recursion. So like this will be happening like every time in our function. Like let's say def recursion. Like
I
every
guess
time we
you,
call the
you you
function.
can just go ahead and start implementing. We'll just work out the details because
Yeah.
yeah, you already have it there.
Okay. Cool. Cool. So I'm thinking def tick tag. I'm just gonna say tick tag, and we're taking in a board, right? Do you need to type it or?
No, you're good.
Okay. Cool. So we're taking a board. This board is it's 3x3. So I could just already set that n is equal to 3. Then have all of these, which I will set as. Is it all right if I name it as default dict? Because I know, is that okay?
Yeah, you could do default dict.
But wait, will I even
I
need
did.
to use default dict?
You just need to import it. Probably.
Uh, Actually, I won't. I won't be using it. Don't worry about it. Don't worry about
It's all good.
it. So call, row, pause dag, neg dag. These will all be dictionaries. Okay. These will all be dictionaries, which will map. Wait, where's the hashtag? Oh, I already have these up here, so there's no need to even write it down again. But then, so these will all keep track of all the columns, rows, things like that. And I have to also have the scene set, which will keep track of all the rows, columns that we've seen. Then we have our recursive function, and this recursion will keep track of is x, and obviously this would start off with is x is true. Then I think the first base case, if len scene is equal to, let's say greater than equal, just to be safe, greater than or equal to 9, then that means we've seen the whole board. So then we can count. We have to have, sorry, we also have to have the result count equal to 0, and then I'm going to set non-local result so I can update it safely throughout the recursion.
Sure.
And now if our length of scene is equal to 9, I'm trying to think, because I actually don't want to check this yet, because the length of scene can be equal to 9 and we could have a valid solution. So
Yeah.
I'm not going to use this one yet. So I'm not going to check this one yet. I'm going to first check the, I'm going to first put in the loop. I already know that for I in range 3. So I'm going to put it in. Then for C in range n, this would loop over every single cell, and we check, okay, if the row column isn't in scene, then okay, 1 second. If is x, then obviously the index, I said here, index 0 will appear in 913. Index 0 will be the amount of x's in the current column, and index 1 will be the amount of y's. So I'm just going to set here index is equal to 0 if it is x, because that's the thing we'd be incrementing if it is x, else 1. So now if the current cell is not in scene, we would increment for a call, row, pause dag, and neg dag, we would increase the count for that specific roll, column, pause dag, and neg dag. So call if I think a default dict might be useful here. Actually, no, it's fine. I'll just use this. I mean, it's okay. If no, not in call is equal to 0, 0. I'm doing a video, mom. Oh, sorry. Okay, not in call. Oh, that's not the syntax. Call C. Oh wow, I'm checking if a row is in a call. Nice. row R is equal to that. So if we don't have we have nothing already in the row, so we set it to that, then we would row R at the specific index equals to plus equals 1. So obviously, if this is X, this would increase the first index, and if it's Y, well, not Y, if it's O, then it will increase the second. Now, okay, if column is, this is gonna get pretty long to write. I think I just copy this. C not in call C is equal to that, and sorry, this is gonna take a long time to code. If or C not in Isaac. Or minus C 0 0. Sorry, my keyboard's not working. Oh. Okay. Okay, we're good. All right, then for neg dag, same thing. R plus C neg. Let's see. R plus C is equal to 0. Okay, so this is all right. Then obviously I do the same thing. Call C at that index. That's equal to 1. So this is updating the fact that we've seen in X or O. Pause dag. Next, let's equal 1. Neg dag index plus equal 1. Okay.
Could you go
Now,
over this code over here? Just want to
yeah,
make sure I understand you.
Okay, so we're first checking the cell. Okay, this current cell hasn't been seen that we're looking at. So now checking, we're adding these in, these like the default values for the dictionary. Because obviously we're modeling them as I seen here. As I said here in line 13 to 16, that you like a call for call, it would map column number to list containing first index being how many X's we've seen so far in that column,
Okay.
and then then next index would be how many O's you've seen in the column.
I see. Okay.
So then obviously this is like we're choosing this current row column, so then we're updating it.
Okay.
For that row, we're adding the fact that we've seen one kind of thing like that.
Sure.
You know what I'm saying?
Yeah.
Now I feel like before I make this check, before I increase this count, I might check if we already have 3 in that row column, pause dag, or neg dag. Because if we already have 3, I'm trying to think if I should check this before incrementing or after. That's what I'm thinking right now. Okay. If we check it before, that means okay. That means you're waiting until we see that specific row column again before we then increment. But what if that was the very last column? What if that was the very last row column? Then we'd never check it. Okay. I think I check after the incrementation. So like after here, I then set like sorry. Equals to 3. I feel like I might change this later, but I'm just putting in now. If row for that current row is equal to 3, then our results will be plus equal by 1. Trying to think where this would go wrong. After we increment. Okay. That current column. Oh. Basic one. Pause diag. Okay, sorry, I forgot to put in the or am I to see here? Oh, sorry. The RBC here. Okay. So for actually you hear your keyboard mashing. Jeez.
Mine?
Yeah, your keyboard is really loud.
I'm just talking in the chat.
That's good, that's good, that's good, that's good. Or what to see
And I'm
index.
writing some notes too.
Cool, cool, cool. No problem. I was like, or minus C. Oh, okay. So one let's see, it's 3, and we result. Okay. Okay, okay, okay. Then okay. All right, all right, all right. Now it's where I then call my function again. Okay. Okay, 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 okay. We call it for this. We increase. Okay, so obviously, like we found a solution, we're gonna return straight away, kind of thing. Okay. And then obviously we'd only reach this line of code if we haven't had a solution yet. So then we call our recursion on not is x. Oh, recursion. Oh. So then this will simulate then changing the turn to be something else. So I'm just gonna oh, nice index in here. I'm just forgetting stuff at this point. Index in here. Okay. Now, all right, let me just read this from top to bottom. This is a lot of code. Just make sure I'm doing this the way I'm thinking. Call row, pause dag, neg dag. I've set the dictionaries out there. Our scene set, I have not added anything to the scene set. Scene.add row column. Now, after the recursion, I then want to remove scene from the, I remove the row column from scene. I believe so. Yes. So this is, okay. Yep. I believe so. Yeah, just to like, this is how my backtracking would work.
So you add.
So,
okay, go ahead.
I add the row column. That's me simulating. I've placed down an X. I add the row column. So like, let's say this is X's turn right now. Let's say I place an X at row 0, column 0. I can then I'll add that to the scene set and then continue the recursion with that X there. Or I don't use that X and I continue the recursion without placing any X there.
Yeah, that makes sense.
Recursion. No. Oh, sorry, that is. Oh, this is not clicking. Oh, my keyboard keeps bugging. Sorry. It's just plugged out. Okay, and we're good. Okay. Okay. All right. Now I'm just thinking now, technically this tree could end up because of how I'm choosing to go without adding anything, we could just, if I was to just continue with how the code is right now, it would just go infinitely. So now how do I keep track of
Why? Where would it go infinity?
because I call recursion, let's say I call recursion not is x if I don't let's say like the decision that I, in the case where I choose to not add a x, not add a o, not add a x, I'm trying to think like as we go along through the indexes, Hmm, how do I model this? Because obviously here we're choosing we either place or don't place, and everywhere we go we could place or not place, kind of thing.
Mm-hmm.
So we could end up being at the last index and not place. You know what I'm saying?
We could be at the last index and not place.
Kind of thing.
Or,
Like
or I don't
we
get
could
this
be at.
last part.
Sorry.
Or I don't get this last part right here
Oh,
where we call
this
recursion again.
yeah, because it's this is either this is if we place like we do place let's say the X. We do place the X here. So then now there's something on that board.
Yeah.
There's something on that place in the board. Then we call our recursion on the next go.
Yeah.
Then obviously here is if we don't place on that place, so then we don't then it would still be X's go. I believe it would still be X's go.
Yeah.
Because then do we even need this then? I don't think we even need this because is if we don't place there, hold on. If we don't place here, we're gonna check, we're gonna try to place somewhere else. Because obviously I'm doing this, I'm iterating through all indexes right now.
Yeah.
So I choose to go here or I choose to go to the next one. But X has to choose one place at least every time.
Yeah.
So then I don't think I need to call the recursion again. I think I just need to remove it from scene. That does the job
I think so. So
for
at line
that thing.
64, I put in the result. It should be 255,168.
Huh?
Or like
For
try to test out the code now. Let's get
oh,
it
okay.
running. This is
I'm
the answer supposed to be.
supposedly I just want to run through just make sure I don't hit
Yeah.
an infinite recursion though. It's like at what point does my recursion stop? That's what I'm thinking right now. If len scene, yeah, I think I can use if len scene. Hmm, hmm. Ooh, ooh, ooh.
So if we get to the end, we want to return none. Or
Yes, but I don't think this is how I want to do it. Call it a function if we get to the or would it just be like after? I think after all the iterations, I just return. I believe so. I think that would actually just do the job. I don't think I need this. Yeah, there's no need for this. I don't think I need this. I'm just gonna run through the code. Just gonna read through the code one more time. Obviously, our recursion starts off with true as is x is true. Our index would be 0. And then we'd start going. Our index being obviously for our dictionaries. Then non-local result, so we can update our result. We loop through every single index, and if a row column has not been seen already, then set the default. We then set these default values for the dictionaries if they haven't been applied already. And then we would see, let me see if there's any bugs here. OR equals, okay. If seen on call, C, okay. Okay, cool, 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 cool. Cool, cool, cool. Then obviously then we'd update the fact that we've seen an X. So an X or no. So obviously left and right index counts for left is for how many X's in that current row, and then right is for how many O's. Obviously here we'd increase the amount of rows, sorry, amount of X's in this row to be 1. Then for each of these would now be 1 and 0. Each of these, the values would now be 1 and 0 as we now have 1x in the row column pos diagonal neg diagonal. Can't
mm,
even speak. Yeah. So that's how that would be updated. So I believe that updates it correctly. After we update it, we've placed something here now. We're checking if we have a valid solution. If we do, increment our result and then return straight away. And then Yeah, after a return at the very end is pretty much pointless. Don't know why that was even there. And then yeah, okay, okay. Now, what if we reach a draw? That's what I'm thinking. How my code would
That should
act if we
count
reach a
up.
draw.
Yeah,
It should.
good
Hmm?
question. Yeah, it should count as a result if it hits a draw.
That counts.
Yeah, like we're looking for a number of finishes, so it includes wins and draws.
No. Oh, number of. Oh, not
Yeah,
number of wins.
yeah, like how many ways a
Okay.
game could finish. So it could finish at a draw.
Okay, didn't mean the game could finish. Okay, fair enough. So now, how would I know if there's a draw? I check if length of scene is if the length of scene is 9, then it's obviously a draw. But where do I make this check? Is the question. I think I can make it at the beginning. Hmm. I guess I could make it after this. Equals to 9. Then we return. Once we, yeah, we return and obviously increase our count as well. I think this can work. Yeah,
How would
so
you
this
test
simulates our
it?
draw. I'll test it. Let's run. Given the fact you've showed me the answer is 255,000, I doubt I'd be able to dry run it.
Oh no, let's not dry run it. Let's just like how would you test it if we can't dry run it? Yeah, it's a
Okay.
massive result. Lots of different paths.
Okay. Wait, I don't know why I'm taking in board as input because board. Will there be any input? Because you said the board is 3 by 3.
Yeah, there doesn't
So
have
there's
to be. It all depends.
okay, then there doesn't really have to be an input. So I don't know why I had board in there. All right. I guess I could print out tick tic tac and see exactly how this works. Mhm, mhm. I'm gonna hit run here. Wait, this drawing mode
Let's hit it.
is
Key error.
okay. Where are we at? Oh, this is supposed to be nagdag. Nice work. All right. Let's run this again. Oh, I did not return a result. Nice. All right. So I have to call the function, and after the recursion is done, return result. 10. Okay. 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 Let me see what's going on here. Okay. Hmm. Let me try to debug this with my eyes. I'm gonna go just look over my recursion logic here. So 0 if is x else 1. Okay, that's cool. Non-local result. Cool. Now row if row column is not seen, then we perform all of these operations. Okay. Set these. Okay. Row R index posag. Posag is R minus C. Okay. Nagdag is R plus C index. Where am I going wrong? Okay. Recursion not is X. They remove it from scene. Go again and again and again. I'm gonna go to the drawing board and see how maybe if I can try to model this. Delete everything that's been made so far. Just head over to the drawing board so you can see what I'm doing. All right. Oh no, wrong one. Okay. First index, we know it's an X. X is not in scene. We set out our defaults. Then row or index plus equal 1. Our index equals plus equals 1. I'll see index plus equals 1. That's increasing the amount we have for that one. Okay. All right. I feel like this return logic here could be an issue. The checking if we have 3. Because obviously I'm checking it after I increment. But what if we actually never? We will always see again next time. And c equals 9. Result plus equal 1. Okay. I'm increasing the amount. So obviously I need to reset. I think I need to wait. I'm seeing that. Yeah, because obviously here the row for this specific index that we're at, let's say we had 3. Yeah, I think that's the bad. No, yeah. Okay, so obviously now if we have 3 X's or O's, let's say we have 3 X's, we'd increase our result and then we wouldn't continue with that. But we could continue with that index. No, we could. I'm trying to think like we could continue with that index with an O.
So we're getting less results than we wanted to.
Yeah.
Is there like I would take a look at the state. Are we reverting the state back to where it should be, like when we backtrack?
Yeah, that's what I'm kind of thinking here. Like obviously here when we see um for that specific row index, it's equal to 3. We increase our result, then we return. Then obviously that previous function call is going to continue with the same value of 3 when it shouldn't. So I need to decrease that as well, is what I'm thinking. Okay. So obviously, like, yeah, I think I need to decrease that as well. Okay. Okay. I think I need to. Yeah, so we increase our result, then we then decrement and then return back. So then that can do whatever else it wants to do with the previous function call. I believe so.
And for time, probably only have like 5 minutes left.
Oh,
Yeah,
that's
because we're at
great.
50.
All right.
But like, let me take a look at that. But then we're only gonna decrement that row when it completes. So it'll only ever decrement back down to 2, right? Like for a row.
Wait, let me actually think about this. Okay. Okay, you're right. But I'm now thinking if I decrement before adding to scene after. I feel like I should be adding to scene like up here or something. It doesn't really matter. That's it.
So what does adding to scene actually mean? Like we're making that choice, right?
Yeah, it just means like yeah, we're making that choice. We're choosing to place down the X row.
And then what does remove do? Like we're taking back that choice.
Yeah, we're taking back the choice. So
Okay.
obviously taking back the choice, I believe, is when I should be decrementing. But
So
hmm,
what did this do? Did this also counts as making a choice or no?
this is also making the choice. This is making the choice, and scene.add is also making the choice. After we call the recursion making the choice, we then remove it from the scene to take back our choice.
Mm-hmm.
So at the point of taking back our choice, hmm,
Yeah. Like when we take back our choice, what do we need to also take back?
the the amount of X's or O's that are in that specific. Like obviously, I think here we'd have to have some decrementation. I think so. Then yeah, so then the state would go back to the way it was before. I believe so. Now we're at 27. We're
Going
getting
up.
closer.
Yeah. This is-
We're getting closer.
Oh, what's
Okay.
this?
Uh,
Wait, what is this?
oh, what is that doing there? Yeah. Still at 27. Yeah, I know I definitely have a couple issues with the way I'm updating my state. Just can't entirely see it right now.
What
Mhm.
about the? Oh, okay, wait. You have length scene.
Uh, Hmm. See now remove RC. I just know it's just one thing I'm missing, and it's just
Yeah.
blanking off in my head. Hmm. Adding to scene, checking the scenes equal 9. Result is equal 1. Okay. So that seems equal 9. We have a full board. A full board with that solution. We return. We call the recursion. If you don't have a full board, then we call the recursion.
Okay. Hold up. I wonder if we move this out to the base case, if it might work. I mean, the code is kind of. I think the code is like 90% there. But I think
Yeah,
with just how you're handling the base case, well, there's no real base case. You're kind of handling the base case within
the
like the
code.
for loop.
Yeah.
The base case should
Uh,
be handled usually outside. But that was one of the things we would talk about. But let's just pull it out and see if it actually just works.
Obviously, like you won't be able to see row or
We
column
won't
because I'm not
know
keeping track
exactly.
of the row column. That's why it's like,
Because usually when you recurse, then
yeah.
you want some base case right here, right? Base case. Because
And then
maybe, or hold up. Maybe instead of return, we just go continue. Yeah, let me add that
continue.
code. Because what it's returning in the for loop, so it didn't really get to try all the different spots though, right? So like it's
That
in the
is
for
true.
loop. So I think it could early stop. Like we want to try stopping it at all the different, or it won't loop through all the rows and columns possibly here because it'll return.
Well, obviously, like I'm returning early because like we've seen a solution. Like you can't legally place again,
Hmm.
kind
But
of
can you
thing.
try the
But
next spot?
obviously, yeah, we can try the next spot. That is the thing, though. Okay, so we're thinking like a continue here instead of return. Is that what you're implying, or no?
I think yeah, we don't want to. We probably don't want to return, but we don't also want to like recurse again. But we also want to like take back that state, so it gets a little.
Yeah, it's a lot of different stuff we want to do. Um, I guess okay. we can, let's say if we remove all these return statements, obviously like at a given time only one of these would be true. Now after we've performed all the checks, we'd want to just hmm, we want to take back that decision as well as continue. I feel like with the way my code is formatted, it's gonna be a little bit long to do. And you said we already have time,
Yeah, we
right?
can.
Mm,
What we could do is maybe just like a condition here on if we want to recurse.
hmm?
Like line 62, maybe we could just add like an
Yeah.
if statement here, like if we want to recurse or not. Because if it's already done, we don't want to actually recurse, but we still want to like perform this, right?
Okay.
This is the
Like
hash.
if not done, so like what? If we're not done, then yeah, perform the recursion kind of thing. Well,
Yeah,
obviously, like in the
that might get you there.
just might kind of thing. Maybe let me think.
Like down here. I feel like it's gonna get closer. I mean, it's way higher.
Ooh.
It might count double count like if.
I don't know if that'll make much difference. I'm just
No,
trying
it's
shit at this
just
point. I don't think it'll make much difference. Oh, made a little bit of a difference.
what about this? This. No, the code is very similar to what would work. No,
Yeah. So yes,
it's getting close. Let's see.
it's getting really close right now. I think I'm adding to scene should be before this then. Maybe. Same time I'm doing all these checks. If I can run it now. And
Let's
capiche.
go!
All
Woohoo! Clutch. Right before
right,
the
we're there, we're
hour.
there.
All right, so
Oh gosh.
how would you optimize it? Or like what would you clean? Like
Optimization.
not I mean not optimize, like how would we how would you clean this up?
Okay, let me look through right now. Because our time complexity is through the roof at the moment. Uh, hmm. So recursion. Okay, I feel like the dictionaries we have are needed. I feel like the dictionaries are definitely needed. I'm thinking of space right now. Like the dictionaries are needed because we do need to know how many X's or O's do we have for every given place, every given direction. So I think those are needed. Now, in terms of the complex, like actually, like, do we need to go over every row and column? That's what I'm thinking right now. But I feel like we do because at any given time we could place anywhere. Um, usually with these kind of questions, there's some tabulation way that just that minimizes the amount of right. I mean, minimize the amount of function calls you have to make, or some. I'm just thinking if there's any way I can memorize this. Hmm. At what point would we reach the same state? That's what I'm trying to think. Memorize. The point where I reach the same state. Hmm.
Or I think maybe like how would you clean up the code if you were to look back on it real quick? Like what are maybe name a
Okay.
couple of things you would fix or change up
Yeah,
to
in
make
terms
it
of okay.
simpler.
Cool. In terms of cleaning up, maybe like I could actually have made all these default values beforehand because like
Yeah.
there's only three. Like I know I definitely could have done that. Could have done us all beforehand. Um, and here, I think these are fine. So like obviously doing this beforehand would reduce all these on these all these if checks all the time.
Yeah.
Then done equals false. All these checks here, I believe, are supposed to be the way they are. But I don't think I changed the way these are right now. Let me think. Row index. Yeah, because we do need to check for each one, then set done to true.
Mm-hmm.
Now, I mean, we could make this a bit different, but I think it would just look kind of ugly. Like, obviously, we could use like some. I believe in Python there's the function some. I don't know if that's in JavaScript or Python, but yeah, a function sum, and then obviously we could have an array of like row index equals a thing, and then like I have all the conditions in there, and then
Yeah.
like if one of them is true, then I guess I'd minimize the amount of lines of code, but like I don't think
Yeah.
that'll actually do any better in terms of complexity. Then obviously, if not done, recurse, then remove from scene, then decrease. I think this is fine. I think the rest of it pretty much makes sense.
Makes sense. Cool. How
Yeah.
how was that experience? How do you think you did?
I'm not gonna lie. Fact that I was kind of messing up the, I was kind of messing up the whole updating the state thing. I feel like if I was to rate that out of 10 or like a 6, honestly, I don't think it was my best. I don't think it was my best shot, to be
Yeah.
honest. But I believe
How
like I had the logic down, so like
mhm.
that's 100%. I feel like I had the logic down. Just them writing out the code wasn't really the best.
Yeah. How
I
did
believe
it
so.
how was it like when you got the question? Did it look like it was much harder than you were expecting or
It was kind of like not really. Like kind of, yeah, like a little bit, yeah. But I didn't think, oh, this is like an enormously hard question.
okay.
I knew like I felt like it was a question that I would be able to get the logic down. I'm saying, but might have some issues with the code. Yeah,
Yeah.
that's how I saw it. So yeah.
Yeah.
Mhm.
All right. Let's look through my notes. I think yeah, you it was good like you thought about the traversal up
Mhm.
front. So you're thinking how am I going to traverse to an end state? And then we had to just clarify what it means to get to end state, which is like the path that you take and not just like the final end state. I think that part was good that we're able to talk through the traversal. But I think the part that
Mhm.
I had to mention was like how we're gonna store the state and how we're gonna track turns, or like prompt that discussion, because the important part of this question is how are we gonna model the state. So you could actually model the state here in multiple different ways. You can just have like a 1D array. You could actually have it a 2D array. You could even have it like a bit mask, but yours is kind of like with a bunch of dictionaries, which was interesting. It ended up working, but
Mhm.
yeah, I would say like there's multiple ways to do it, and this one works, but it might be hard to like convert this to a DP with the way that you modeled the state, because the optimal solution is like caching the state, and like how many ways that you can get to an end state from a very like from a specific state.
Mhm. Yeah, and
So
I know like given the way I modeled the state, like there wouldn't be a way I can really
yeah,
memorize this.
let's see. You mentioned backtracking. Yeah, your initial approach with backtracking, but then you went back on it after a bit. I think with a lot of things, you explored it and then you went back on it eventually, which was good because like you're able to like figure things out, and you're figuring a lot of things out on the fly.
Mhm.
But some paths
Mhm.
you explored longer than you should have, which why like it ended up taking more time. Like for example, with some of the backtracking, like putting X's and then trying the X's again instead of having to alternate. So I think I had to prompt that we had to alternate there.
Mhm.
Um,
Mhm. Mhm. Okay.
let's see. Yeah, the main part would just be talking about like how to model, or the recursion should have like some sort of base case. Like you kind of handle the base case within here, and that complicated things. So usually the
Yeah.
base case is handled here, and then we'll have some recursive case. So here, like I would try to refactor it to a way that it would just get here and then return.
kind of thing. Okay, so like
Yeah,
obviously like I keep track of the row and column as I go along.
yeah, and then
Okay.
yeah, like figure out some base case and a recursive case to clean up this for loop. And then yeah, I think the main thing that you're missing was just like reverting the state. So in the backtrack, you like make a decision you want to take it back.
Mm-hmm.
The part that you got stuck on was that you like added it to the state, but then you didn't remove like revert the state.
Yeah, 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 yeah.
Yeah.
Like just
So I
mess up
think
with the backtracking. Mhm.
yeah. So I think when it comes to the backtracking, just making sure to handle the base case and recursive case, and then the main part is like making decisions and taking back the decisions as well. But other than that, I
100%.
think you're able to get to the like you modeled the grid in a pretty cool way that I didn't expect.
Mhm,
Um,
mhm.
but yeah,
Okay.
cool.
Um,
Now,
all right.
yeah, the only thing would be like if you got down the first, we'd probably move on to like the dynamic programming version. But I mean, it's like chat was even saying this is a hard question, so I didn't expect it.
This was one of the harder DP problems I've ever done,
Nice.
I'd
Oh, at
say.
least you're able to like unblock yourself and get close to it.
Yeah, I guess I got the logic down anyways, but,
Yeah.
what was I gonna say? I This kinda sounds similar to N Queens.
Yeah.
I was thinking that might be your follow-up.
I don't know if end queens you could actually cache though. Well, actually, it depends on end queens number. Like depends on the end queens number, but it's very similar to end queens.
Yeah, because yeah, because like, I've done N Queens before. It was like
Mm.
there wasn't the way I did it anyways, there wasn't a way to cache it.
Yeah, because I think for that one they want you to return the number of. They don't want you to return the number. They want you to return like the actual states that it could finish.
Oh, yeah,
But
that I think
then,
that was N Queens 2, or was
oh,
that
okay.
1? Which one?
But there's one
Like,
that I think you could do a DP. Because I know
yeah,
for
yeah,
this
for
one
sure.
you could do a DP. Like I got asked this one for a company out here a few years
Oh,
back.
you did?
Yeah, this is like a actual interview question that I got.
Okay, how did you go with that one?
Pretty
How did you
much
go
the
about it?
same. Yeah. The thing is I did it's been a while since I did DP, so he made me optimize it. It was like a short interview.
Mm,
So took me forever to like I couldn't figure out how to model the DP. Like how
yeah,
to make it
honestly, it
into
was
a
just
DP.
modeling yeah, like, modeling the state here is like it's a lot of different things to keep track of. That's what increases difficulty here,
Yeah.
honestly.
But yeah, there's probably easier ways to model the state. But I think like
Yeah.
you could just do a 1D array as well.
1D array?
So yeah, you could just do a 1D array with like the zero, zero. Like you could just say like what decisions were being made. Mhm. Like if it's just like a 1D array of none none. And then you could just
Okay.
like hard code which ones are actually like verticals and horizontals. So the verticals would be like every second one kind of thing.
Yeah, that is
Yeah.
true. Yeah.
Or the way that I did it when I got asked is just like a 2D array. And then I would just like to make a decision, I wasn't incrementing all of these. I was just like placing it inside of the array, placing it inside the state.
Okay.
Cause and then to revert it, then I would just like null it out. So it'd be like everything's none. You could also
Okay.
model the state like that. There's multiple ways, but I think yeah, that your way is interesting. But yeah, cool. Thanks for taking the time out. Do this again sometime.
For sure. For sure, for sure, for sure.
Are you
Thanks, man.
headed out now?
It's pretty fun.